Hi, this is Dr. Don. I'm back with Data Wrangling Part 4. We've imported our data into StatCrunch. We've graphed it and taken a look at it. And now we want to start doing some basic analysis of our data. The first thing I want to do is to get summary statistics on my variables. And the way we do that is to click on Stat, Summary Stats. My variables are in columns. And you can see that I've got these variable names popping up there, which is what I want. I'm going to just select all my variables. And then I want to get some statistics. I want count. I'm going to hold down my control key, click on mean, variance, standard deviation, standard error. Standard error, remember, it goes into getting the confidence interval. Median, range, min, max. Click on that again. Q1, Q3. Don't need the sum. I'm going to get the interquartile. And we don't worry about the unadjusted variance and range. And I'm not going to worry about anything. I'm going to go ahead and get the mode just for the fun. And I'm going to click on Store in Data Table. If you're wanting to save this data, easy way to do that would be to click on Store in Data Table, and then you can work with it. I'm going to go ahead and click that, and I'm going to click on Compute. And it takes a couple of minutes. I'm going to move this over and move. Whoa. Okay, there's my data, and it tells me it added all these columns. I'm going to get rid of that, and I'm going to expand that first one so I can read that. And there are my summary statistics, my descriptive statistics for these variables. All of them have 1,000, which I'm glad to see that. We've got the means there, the variance, standard deviations, standard error, and then we have other information, the median, min, max. You can see there for these two variables, male, female, and LP and RN. There's only 1 and 2, obviously, and some other information, about each of these variables. So that's useful, and you get that data. If you want to save this data, what I would recommend doing is to copy it into Excel so that you can manipulate it later on and pretty it up to put a report. And you can do that just by highlighting and dragging like you do in Excel. Control-C to copy. I'm going to bring up an empty Excel workbook, put my cursor in the first cell, Control-V to paste, and there I've got my data in Excel. I can do more manipulations. I can copy, pretty up this table, or I can put it into my Word, my report, and use that data that way. So that's useful. The next thing I think I want to do, I want to look at how accurately my data set will give me the means, for example. And the way we would do that is calculate confidence intervals. And StatCrunch will do that very, very quickly for us. We go again, Stat. I'm going to go down to T-stats, because generally we use T for confidence intervals. Whoops. One sample data, and bring up this dialog box. I'm going to start clicking on the variables that I want to get confidence intervals on. I'm going to hold down my control key, click on skills, training relevance, training helps. Meaningless to get confidence interval around LPN and male female, but I do want to get education, outpatient experience, age, years license. And all we need to do, go down here and click on confidence level for the mean. I want a 95%, which is traditional. And to make it easy to get into Excel, I'm going to click on Store and Data Table again. And then just click on Compute. And we get the little message that says that added all these columns. Let me scroll over here so you can see it. Here are my variables, those 8 variables that I wanted to get the confidence intervals on. I've got my mean, standard error again that we got from descriptives, degrees of freedom, which is, for t is 1 minus n minus 1. And there I've got my upper and lower limits for each of these variables. And that might be something useful to report about your data. These are very tight confidence intervals. And the reason for that, I have such a big n of 1,000. If you've only got 5, 10, 15 in each one of these variables, then you're going to get a bigger, wider confidence interval. Remember, we talked about that. So get the confidence intervals. That's pretty straightforward. One final trick I'll show you to get rid of this data. It took me a while to find that out because again, I'm going to Control C. I'm going to get it back into my Excel, and I'm going to paste that data in there. So I've got my control limit saved, and now I've highlighted those cells, Control X, whoops. Once you do that, you got to highlight again. Control X deletes those, cleans that out so you're ready to go back to work. Okay, we're going to do some more analysis here. There's just any number of things that we can do with our data in StatCrunch. The first thing I want to do, I'm going to assume that we've run this survey before, and for example, on our understanding training variable, I'm going to just say that in the past, the mean has been 3.9, our mean for past tests. So let's see if this batch of people, if their mean differs from 3.9. We go to Stat, ZStat, one sample with data. And I'm going to select that first variable, understanding training. Leave these optionals alone. I want to run this hypothesis test, and I believe the mean from our history is 3.9. And so we want to know, is this current batch different from the historical record that we have for that particular variable? Click on Compute, and this points out something that you should know, particularly as you start getting into big data, and a data set of 1,000 is getting into big data. The larger the n, the smaller the effect size has to be in order to get a significant outcome. In other words, the difference between the observed and the expected can be very small and still be significant if you've got a very large n, and that's the case here. The mean for our sample is 4.035. The population mean from the past is 3.9. That's just 1/10, a little over 1/10 different out of 6. That's pretty small, and yet it's significant. P-value is less than 0.05. So that's an interesting test. And what I would do, if you've got some assumptions about what your data has been in the past for these variables, run z-test if you've got enough of an n. If you don't have enough of an n, small sample, run the t-test and see if the current sample you have varies significantly from the past. So I'm going to stop with this test right now, and then we'll continue in the next section of this video series.